Hello people, welcome back to this new episode of my experiment number 8, that is real-time ML model monitoring and observability. So in this experiment or exercise we're going to see what is Prometheus and how it is going to be used in post-production, that is after production, checking that if the model works better or if the model has a model drift or something like that. So let us get into the main concept. So objective of lab experiment is to just integrate a major part in a machine learning training pipeline, that is the post-production monitoring or logging. So in this we have system logging, as this PPT says. It records audit after post training. So after the training, when we deploy the model, the system would be logged, like what is the configuration, how much computer resources has been used. All these things will be monitored through we will learn it through this experiment. Of course, we have real-time metrics. So as the model is being deployed and being used, so we will as the model predicts the answer, side by side accuracy or maybe the hallucination or F1 score will be monitored in real time. So we also have a visual progress where I create dashboard which says about loss or accuracy, and of course there will be a custom callback, so automatic monitoring in TensorBoard pipeline. So this is very simple system architecture. We have a model or data set and a monitoring set. For model, we have a simple neural network, MNIST handwriting data set. I guess it's from Keras or from sklearn-kit, and it may be differs based on situation. And of course, we have TensorBoard and Keras framework. Of course, for monitoring, we use log files, that is mlsystem.log. We have Prometheus for metric scrapping, that is getting the data from the model, and we just run it on a local 8000 port. This for visibility, and of course, we have TensorBoard visualization. And of course, our entire experiment is our 5 step, that is data preparation. We just normalizing it from 0 to 1 by dividing it by 255.0, and of course we just flatten it, like converting a 2-dimensional image to 1-dimensional vectors. And of course we write a dense hidden layer code, that is 128 units of neural nodes along with relevant activation functions. We also have a dense output layer, that is a fully connected neural network output layer, which contain 10 units of softmax class probability, because data sets has a class from 0 to 9. This suits 10 units. And of course we have a model compilation of Adam, that is a combination of Padagrad and something or other. I'm not sure about it. We have Adam optimizer along with SEC, that is sparse categorical cross entropy loss. So our strategy will be with we just have a Python logging model in order to log the file, and of course we have file configuration. The log files should be stored in mlsystem.log. We have a structured format like a timestamp, level, and a message for easy understanding to make it human readable. And of course we just made all this for debugging purpose. Like if it causes any error in the post production or in post training, it will be easy for us to monitor and debug the stuff. We have a gauge matrix that stacks value goes up and down like a speedometer, like as you know. If the accuracy is very more, the speed would be very high, or the point would be 0.2 minutes my right, I guess. And of course, if the accuracy is very low or loss is very high, the speedometer or a needle will show at the left. We also have HTTP server which runs on port number 8000. Like this TensorBoard visualization, it runs an HTTP server, and of course we have a live monitoring. So this is the stuff, like we defined a class for monitoring callback, and of course we have approach end method in order to monitor after each endpoint. And of course we extract a metric, write it as a log, and update the gauge or the speedometer stuff. So this is the result, but before getting into it, let me show you the file which I just ran. So this is the libraries. As you can see, we use logging library, TensorFlow STF, callback from Keras, and of course we have Prometheus client in order to get the gauge and HTTP server. This is the class, or this is the method, sorry, method in which we just store all the logging information, the format of the configuration of the login. So we have file name, we have levels, and we have the format, that is ASCII timing, level name, and message. Of course, we have the gauge or speedometer kind of thing, which says about training loss, and of course we also have about training accuracy in that stage. And we just start the HTTP on a port number 8000. We just define a class, as we said before, a monitoring callback class, in order to just define, like, after every approach, after every training approach, the model should send the accuracy loss metrics to the log files, so that it will be stored and it will be easy for us to monitor. And of course the regular training stuff, that is we just split the data set using load data, and of course as you know, all this stuff we just normalize it over here. We just define all neural networks over here. We have flatten layer, we have two dense layer of activation and softmax. We also have atom, and of course we have space categorical cross entropy, and we also have metrics accuracy. We use a try catch method in order to just use the callback method or TensorBoard method, so that if at all it fails, you just fall back to a better state rather than error state. So of course we just trying to print using the gauge, that is the speedometer here. So let me run this entire program once again. Okay, I select a kernel. So now you can see the application running. Just clear all the outputs and let us run it once again. You can see the things over here. I didn't set up the TensorFlow GPU because I have only Python and PyTorch enabled GPUs. Like, I didn't set a configuration for TensorFlow for this particular GPU, that is Coda version and stuff like that. So that's why you can see this output over here. And of course we had a training script, and we have Prometheus running. So let's hope for the best. Yeah, as you can see, the log files over here. So you can see all the versions, we can see the training loss and all other stuff. So this is how Prometheus work. It's running on port number 8080. So here you can see the TensorBoard. Here you can see the TensorBoard dashboard. We can see the training, validation, and all its accuracy values. And of course we can see in the elbow curve over here for validation, and an elbow curve over here for training. We also have the depot stuff, learning rate for each approach. So that's it for my side, and see you on next video. Bye.